In this video for Positive Maths, we're going to look at Junior Cert Higher Level 2014 sample paper. This is question 7 from paper 1. Given any two positive integers, m and n, where n is greater than n, it is possible to form three numbers, a, b, and c, where a is equal to n squared minus m squared, b is equal to 2nm, c is equal to n squared plus m squared. These three numbers, a, b, and c, are known as the Pythagorean triple. So part 1. From m is equal to 3 and n is equal to 5, calculate a, b, and c. So a is going to be equal to 5 squared minus 3 squared. So that's 25 minus 9, so 16. For b, we have 2nm, so that's 2 multiplied by 5 multiplied by 3, which is going to give us 30. And for c, we have n squared, which is 5 squared, plus m squared, which is 3 squared, so that's 25 plus 9, which is going to give us 34. Part 2. If the values of a, b, and c from part 1 are the lengths of the sides of a triangle, show that the triangle is right angled. Okay, so I'm going to draw a quick sketch. So the longest side is going to be 34. And mark this as 30 and this is 60. So it's not drawn to scale. In order to show that it's a right angle, what we want to do is use the theorem of Pythagoras. We want to show that 34 squared is equal to 16 squared plus 30 squared. So 34 squared is going to give us 1156. 16 squared gives us 256. And 30 squared gives us 900. So we have 1156 is equal to 256 plus 900. So we can say, therefore, the triangle is right angled. Part 3. If n squared minus m squared, 2nm, and n squared plus m squared are the lengths of the sides of a triangle, show the triangle is right angled. So we're going to do the same thing here. So this is a, b, and c from the previous part, and we already showed that a and b, if we let them be the sides, and c be the hypotenuse, then we can show that it's a right angled triangle. So again, we're going to show that c squared is equal to a squared plus b squared. So instead of c squared, we have n squared plus m squared squared. A squared is going to be n squared minus m squared squared. And b squared is going to be 2nm squared. So we're going to get rid of the brackets on both sides and see if we can simplify. What we want to end up with is whatever is on the left, we want it to be equal to whatever we have on the right. So our first one, n squared plus m squared squared. So we square the first term, that's n to the power of 4, twice the product of the two terms. So that's 2m squared multiplied by m squared, and square the last one, so that's n to the power of 4. Same on this side. Square the first, twice the product of the two terms, and square the last. And then 2mn squared is going to be plus 4n squared m squared. So just to recap on something. If we have a plus b squared, we have two ways of simplifying this. We can write out our brackets, so a plus b multiplied by a plus b, and we multiply them that way. Or we can say we square the first term, so that's a squared, twice the product of the two terms. So the product of the two terms is when we multiply a by b. So twice ab, and we square the last term, so that's b squared. So that's what I've done to expand all of these. So what I'm going to do to simplify this equation is to move all of the terms onto the left. So I have n to the power 4 plus 2n squared m squared plus n to the power 4. So that's everything that's already there. So now I have minus n to the power 4 plus 2n squared m squared minus m to the power 4 minus 4m squared m squared. And that's now all equal to 0. Now what I'm going to do is I'm going to group the like terms together so you can see how they're going to cancel. So the first two is n to the power 4 minus n to the power 4. The next like terms are the terms that have n squared multiplied by m squared. So I have plus 2n squared m squared plus 2n squared m squared minus 4n squared m squared. And then I have plus m to the power 4 minus m to the power 4 equals 0. So these two, plus n to the power 4 minus n to the power 4 is going to give me 0. 2n squared m squared, 2n squared m squared minus 4n squared m squared is also going to give me 0. Plus m to the power 4 minus m to the power 4 is also going to give me 0. So 0 equals 0. This is true. Therefore, our triangle is right angled. So the fact that we have 0 equals 0 is okay. We just don't want to end up with something where we have maybe 5 is equal to 0, because that's not true. Or in this case, n to the power 4 is equal to 0, because again, that's not true. So we wanted the equation to be balanced. We want both sides to be equal. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and follow us on Facebook and Twitter. Thanks for watching.